Hello everyone, well done in the exams. I'm going to be using this video to go through the multiple choice and my side of the exam, and I'm sure Mrs. Williams will be putting together something for you to have a look at the other side as well. We're going to start off with the multiple choice. Number one, hopefully that should have been a really straightforward, easy one. Relative atomic mass is always the weighted average relative to 1/12 of the carbon-12 atoms. We've got to get carbon-12 in there. And Avogadro is equal to the number of atoms in 1 mole of helium gas. Now, helium only comes as individual atoms. If we have the atoms in 1 mole of oxygen gas, it's O2, so there would actually be 2 moles of atoms in there. Ions in 1 mole of sodium chloride, you've got the same problem. Grams of carbon in 1 mole of carbon, then that's just, there's 12 grams in 1 mole, and that doesn't give you the right value, even though it is related to the mole. 3, the total number of alkenes and cycloalkanes with the formula, that is 6 if you work them all out. 4, how many electrons are there in 10.1 grams of neon? Neon's MR is 20.2, so 10.1 over 20.2 will give you half a mole, and half a mole times the Avogadro gives you B. 5, second ionisation energy, so that you can instantly rule out A and B because they are going from the element itself. Second ionisation energy must be starting already as a positive ion and becoming a 2+ ion, so the answer there is C. And 6, the melting temperature, the number melting temperatures are given, atomic numbers of the elements, which element is in group 2, that would be B. This first one, very, very low, so likely to be gas, and then you've got solids coming after that. Okay, for the next ones, the correct for the elements going down group 1, you've got melting temperature and first ionisation energy there. As you go down the group, those electrostatic forces between the ions are decreasing, between the ions and the electrons are decreasing because of the charge density decreasing, and that also means that that electron is further away from the nucleus and easier to remove. So it's A. 8, we've got some copper sulfate, and we're going to attract it, potassium permanganate on the other side, and let them move around a little bit. So as they do, the blue colour is going to move towards, which is positive, is going to move towards a negative electrode, which is right, and the manganate colour, which is the negative ion, MnO4-, is going to move towards the positive electrode, which is the left one. So the answer there is C. Number 9, total number of electrons as a molecule of carbon dioxide. We've got oxygen with 8, or sorry, 2 oxygens with 8, so that's 16, plus another 6, so that's 22 you're looking for there. So you go through all the elements that will have 22 electrons, and you come up with N2O. In ethene, the number of sigma and pi bonds. You've got obviously the pi bond in the middle of ethene, but you've also got the sigma bonds going around the 4 hydrogens and in the carbon-to-carbon bond, so you've got 5 in total with 1 pi bond. And then 11, systematic name, we go for the E isomer there. 12, we've got a rate equation. So we've hydrolyzed according to rate equation is most likely to be something that's going to undergo SN1 because you've only got one thing in the rate determining step. So we're looking for a tertiary halogenoalkane, and your answer there is C. Method is most suitable for comparing the rate of a primary iodo and a tertiary with aqueous silver nitrate. We'll be looking for the time to form that silver halide. And 14, the units for Kc. You do need to be careful here because you've got a solid and solid down over there. So they are not going to be involved in the equation at all, which means you've got 1 mole from the copper 2+, 1 concentration on the top, 2 concentrations on the bottom, and then if you cancel that all out, you get B. 15, we've got propene here. How do bond lengths and bond enthalpy compare? Well, simply put, shorter bonds are stronger bonds. A. We've got electron pair repulsion, and we've got 2 different H bond angles. So across that, you've got around the double bond, trigonal planar, and tetrahedral around the other end of the molecule. And so B. And C, the central carbon atom, you've got a double bond, a carbon to hydrogen, and a carbon to carbon. So you'll have 3 bonding pairs, but there's no spare electrons because the other electron, if you like, is in the double bond. So it leaves you as trigonal planar. 16, we've got liquids, diiodomethane, ethanol, propanol, and tetrachloromethane. So we're now looking for something that is very polar. So the most polar of those is tetrachloromethane, and you get D. The coloured precipitate, we're going to be looking for something that can form its own ions and release a halide, which is A. 17, we're looking for oxidation number in thiosulfate. 3 oxygens at -2 gives you -6. You've then got a -2 charge overall, so that leaves us with 4 to find, and so each sulfur there is in the +2. Similar sort of deal here. You've got 6 times -2, which gives you -12, but 2 of those are already covered, so we want to find 10 across the 4, and that would be 2.5 each. Remember, what happens in actual fact is that you get sulfurs in different oxidation states. So we can have the 2.5 as an average, even though it's not quite correct. And then 18, 0.164 grams of the metal nitrate gave 2.5 times 10 to the 3 moles of gas. And we've got to work back to the original metal. So to work this one out, you take the number of moles of gas, which is 2.5 times 10 to the -3. You can work backwards. To be fair, you could do this in either way. But if you do 2.5 times 10 to the -3 and divide it by 2, that gives you 1.25 times 10 to the -3. And because we have a 4 to 2 ratio here, and then to get that to work, you need to times it by the MR. So it's the MR of the nitrate group plus the individual metal, and that will then give you the answer, which is calcium B. Okay, question 19, we've got our old friend Maxwell Boltzmann's. So the main reason an increase in temperature increases the rate is because we have collisions occurring with more energy. Obviously, more of them have the activation energy. Now we're looking at the area due to a catalyst. So the EA cat has moved to the left, and so the additional area that we've got at the higher temperature is both W and X. So we're looking at B there. Question 20, and we're looking at some disproportionation reactions. If you go through all of them, the disproportionation reaction where we have oxidation and reduction occurring simultaneously is D. 21, a secondary halogenoalkane. You can see the chlorine in the middle of the chain there. So we've got A. The mechanism and type of reaction between ammonia and chloromethane. Straight recall there, that's nucleophilic substitution. And 23, you've got propanol and propanone. So the compounds have molecular ions at different mass to charge peaks, being the false statement. We're going to jump around a little bit as we go through the word questions. and hopefully you'll be able to keep up. We're only going to have a look at the inorganic half, the bits that are from my side on these ones. As I said earlier, Mrs. Williams will pick up the others. So write an equation for the reaction. You've got nitrogen monoxide, and we are adding hydrogen, and the products are nitrogen and water. If we look at that, you can see that you've got N2 there, so we need 2 of these, which is going to give us 2 water, which means we also need 2 hydrogens to get our answer there. So deduce the order of reaction. Well, holding, if we compare 1 and 3, and you can see what we've done there is keep the hydrogen the same and quadruple the nitrogen monoxide. Well, at that point, it's gone up by 16 times. So a quadrupling has given us 16 times, which is 4 squared. So that means that the NO is going to be second order. Whereas if we double the NO across here, then we would be expecting a 4-fold increase, 2 squared. What we actually get is 8 times. So you've got the 4 that we'd be expecting from the nitrogen, but you've also got a doubling of the hydrogen, so that means that the H2 is first order. So when we write the rate equation, rate equals K and then NO2, H2 raised to the power 1. To calculate the rate, there's more than one step in the reaction mechanism, suggests why reaction is unlikely to take place in a single step. Well, we've got 3 molecules there, 2 nitrogen monoxides and an H2. So if that's going to all collide together, it's going to be really unlikely if we consider the geometry as well. So you need an answer in there that talks about the idea that you're not going to get 3 molecules colliding at once. And there has to be one collision between 2 molecules, and then the product of that will then collide with a further molecule. And that's how it's going to work. The second step of the mechanism is the rate determining step. So suggest an idea for the rate equation. Well, at the start you've got 2 NOs, so it's quite likely that those 2 NOs are going to give you N2O2. N2O2, and then you can react that with hydrogen, it's told us here. So that's the first step. So we've got N2O2 plus hydrogen, and then we can sort of begin to think what that might make. There's quite a range of things. We could make N2O and water, probably the most obvious, but you could also make hydrogen peroxide, and you could have nitrogen plus hydrogen peroxide. Either of those would work, but it is important that you balance. And then it says justify your suggestion. So there's my suggestion. Why? Because the rate equation must include all the species up to and including the rate determining step. So at the bottom, on the top here, it's given us the 2 NOs. So my one must be the product of that. That's this reacting with the bit left over from the rate equation. So we need to sort of explain that we've used everything that's in the rate equation there. The 2 NOs in the first part step, and then we've used the H2 from the second step. We would then have mole dm to the minus 3 seconds to the minus 1 equals our rate constant, and then on this side we'll have moles dm to the minus 3 squared, and then another mole dm to the minus 3. So if we rearrange that, you're left with moles dm to the minus 3 seconds to the minus 1 over mole dm to the minus 3. That would be now cubed. Cancel one of those, and it's to the power 2. And then when we bring it above the line, you have moles squared, moles to the minus 2, dm to the 6 seconds to the minus 1. If you put in the units into that, sorry, just any of the values into that, you'll come up with a value of 68,750, which you are allowed to round to 70,000 on this occasion, but it was really good that most of you didn't do that. 25, there are a lot of people here that put effervescence, and copper oxide plus sulfuric acid is not going to effervesce, it just makes water and the salt. You'd see the copper sulfate being formed in the solution, which would give you a blue solution. That's one that we'd expect, and that the black powder would dissolve, but there's certainly be no fizzing effervescence. Carbonates, yes. The oxide, no. The ionic equation then, we've got copper oxide, which is solid, reacting with those hydrogen ions to form copper ions in solution and water, which is a liquid. We've then got to calculate our reacting mass question. So we've got 3 steps, moles, ratio, 3 steps, moles, ratio. And then finally here, write the ionic equation for the reaction in solution of any strong acid. We've got hydrogen ions plus hydroxide ions goes to give us water. Answer, and we'll have a look at those here. So first of all, we've got moles of acid, and that is 25 times the concentration of 0.5 over 1,000, which gives us 0.0125 moles. We've got ratio step, where we've gone from 2 to 1, so that means we then go to 0.00625, and then we will times by 24 decimeters cubed, which gives us 0.15 decimeters cubed as our answer. Oh. I realised I skipped over 28 there, so just coming back to it, describing how the flame test was carried out. This question was done really well. Nichrome wire for 1 mark, HCl for the second, nichrome wire, clean in HCl, and then the idea of dip in compound and non-luminous flame to see the colour. Question 29 here, we've got methanol. 2 characteristics of the reaction we needed in here to talk about concentrations of reactants and products being constant. And then a lot of people just wrote the rate of both sides. That literally means nothing. The rate of the forward and backward reactions are equal. That's what we needed to say. But if we're talking about the rate of the side, that's not a thing. So you're not going to pick up marks there. How does the equilibrium yield of methanol change? Well, you can see it's an exothermic reaction. So if you increase the temperature, the amount of methanol is going to decrease. And there's also only 1 molecule on the right hand side. So if you increase the pressure, then it's going to increase. So you have B there. Then explaining the origins of the flame test colours, we've got the idea that heat excites. Then we've got electrons move to higher energy level as they return to ground state. They release the energy as light. Cream coloured, when you add to magnesium bromide, that would be our silver nitrate. And the identity of the anion, soluble in dilute ammonia and concentrated ammonia. Well, if it's a bromide, it should be insoluble in dilute, and concentrated, it will dissolve. Explaining our answer, that's literally what we've got to do there. So we say that we have an exothermic reaction, so the equilibrium moves to the left, and that increasing the pressure favours the side with the fewest gaseous moles, and in this case that's the right, so it moves that way. Part C then, the industrial process. A lot of people talking that catalyst reduces the activation energy, allows the product to be made faster. All true, very good, but it has asked you for it and explain why in the industrial process. So we could talk about the idea that milder conditions could be used, so the idea that you would need to use a lower temperature because you'd make up for it with the catalyst, or that you would make more in the time, but you need to be sort of fully detailed in there and make sure that you're explaining yourself fully, rather than just saying it makes you more money. That's not quite enough. Last question, 31, and we're going to look at the thermal stability trend. So as you go down the group, stability increases. This is because the cations become larger with the same charge, therefore they become less charge dense. That in turn means they polarize the carbonate less, so there is less weakening of the carbon to oxygen bond. And if you sort of write with detail and a little bit of care, and then a lot of you managed to get 4 out of 4 there. Any questions, please do get in touch so that I can help you. Very happy to go through it. I hope that explained the questions, and tomorrow we will keep going on with our Born-Haber cycles and a little bit more about entropy. I look forward to seeing you then.